everyone. Welcome to Vijay Chemistry. And today we are going to discuss the 15 important, the previous year question in main group element. Until now, we are discussing 11 important concepts in main group element. Okay. Based on the 11 important concepts, I'm going to discuss the 15 important previous year question from IIT JAM and the Hyderabad Central University. Okay. I plan to upload the two part. And first part, I'm going to discuss only IIT JAM and the Central University exam. Then second part, I'm going to discuss remaining entrance exam. Okay. Let's start the first question. Read the first question. The compound having the SS single bond linkage is present. They're asking what? The sulfur-sulfur bond. Which of the following oxy acid of sulfur can exist for the sulfur-sulfur single bond? Okay. During the oxy acid of sulfur, I'm going to I taught what? One excellent trick to find out what? The sulfur-sulfur linkage. What is the trick? We know very well, right? The polysulfur acid with SS linkage or SS bond. Only two types, right? What is two types? Only thionous acid, only thionic acid. What is called? One is thionous acid, thionous and thionic. What is thionous acid? S and double bond O and S and N and S double bond O, here OH and OH. This is thionous acid. What is thionic acid? SN similarly and S double bond O, here also S double bond O and here OH and remaining other one double bond O and double bond O and OH. Okay, only these two common, thionous and thionic, containing what? The sulfur-sulfur linkage. Now see, in case of thionous, how many oxygen atom? 1, 2, 3, 4. Our number of oxygen. The number of oxygen should be 4. That is called thionous. Understand? The number of oxygen should be 1, 2, 3, 6. The number of oxygen equal to 6. That is called what? Thionic. Now see the option which containing only number of oxygen 4 and 6. This only 3. Therefore answer is not. In this case 7 oxygen not possible and 8 oxygen not. Only what is answer? Answer is H2 H2O4. Therefore this compound they containing what? The sulfur single bond. Understand? Go for next question. Okay, that's the number of the PO bond present in the tetrabasic acid of H4P2O7. They asking what? This they given the tetrabasic compound. They find out what? The number of the PO bond. Okay, I also teach one trick, right? What is the trick in find out the PO bond? What is the trick? Very simple. If I take ic acid, for example, phosphoric acid, take ic acid, I remove of one oxygen, I get what? I get pyro acid, right? Pyro acid. What is ic acid? H3 and PO4. Okay, I take 2 moles of ic acid, I remove what? I remove the water molecule. Okay, this is water molecule, not oxygen. I remove the water molecule. What is the product? H4 and P2O7. This is what? The pyrophosphoric acid. What is the structure of pyrophosphoric acid? And P double bond O, here oxygen, and here P double bond O, and here oxygen, here OH and OH, here also OH and OH. This is what? The phosphoric acid. How many PO bond? Answer is what? Answer is 2 PO bond. Very simple, right? Take listen. What is S3PO structure? The P double bond O and P double bond O, right? Here OH and OH. This is H. OH. Okay, this is OH. What is formula? S3PO. This one. This orthophosphoric acid, right? The orthophosphoric undergo the dehydration. I get what? The pyrophosphoric acid. How many P double bond O? Answer is 2. Okay. Now go first. Third question. They are asking what? The hydrolysis of CH3 twice and SiCl2 and CH3 SiCl leads to this compound. What is the concept again? The silicones. Now first you take CH3 and twice and SiCl2. Do hydrolysis. I get what? Silanol, right? Silanol. I take CH3 and twice and SiOH twice. This is disilanol. Always disilanol can form what? They can form linear as well as chain, right? Or cyclic. Yes or no? Similarly, we take second option, CH3 and Si and Cl3 and do hydrolysis again. What is the product? And CH3 and Si and OH. Try this is tries and always give the cross the link polymer. Therefore, what is the answer? The CH3 twice SiCl2, they give us the linear chain and SiCH3, CH3, SiCl3 to use what? Always the cross-linked silicones. But the option A is correct for this question. And go for second question. They are asking what? It's very simple question. The number of the 3-centered 2-electron bond in diborane, right? What is diborane formula? B2S6. This is diborane, right? What is structure? Boron, here hydrogen, here also boron, here hydrogen, here hydrogen, here hydrogen, and here hydrogen, and this is what? Diborane, right? Now we discuss this bond should be what? This is 3-centered 2-electron bond. This also the 3-centered 2-electron bond. This bond is what? The 2-centered 2-electron. This also 2-centered 2-electron. This also 2-centered 2. Therefore, how many? This also 2-centered 2. Therefore, how many 3-centered 2-electron bond? The total, the 3-centered 2-electron bond, nothing, 2. And 2-centered and 2-electron, nothing but 4. What is option? They are asking only what? The 3-centered 2-electron. The answer is what? Option 2 is correct. Option A is correct. The containing what? The 2, the 3-centered and 2-electron bond. Okay, this was asked in JAM 2011. And next question, the final product of reaction, the BF3 is water to form. Very important question, please note. Okay, now the BF3 is react with water. What is the product? Now you know very well boron belong to sp2 hybridization, right? They containing vacant p orbital. Now use what? Nucleophilic substitution reaction, H2O. Then lone pair going to what? Attack, right? Cl can minus F can be released. I get what? B here OH, then here F and F. If I do the continuously, what is the product? B here OH and OH and OH plus I get 3HF. Now this excess in solution, right? Now this HF, the react with what? The BF3 again. I get what? The HBH4. What is the final product? HBH4 and H3PO3 orthoboric acid. What is the option? This is H3BO3. Therefore, what is option? Option is B. Okay, H3BO3 plus HBH4. This is plus, this is minus. Understand? Very important question. Please understand. Okay. Go for next question. They are asking what? The number of the pH bond in hypophosphorus acid. Very important question. What is hypophosphorus acid? Very simple, right? Now you know same trick, right? We discuss in oxide acid or sulfur. Same trick. First take ic acid, phosphoric acid, and remove an oxygen. What will happen? They form us acid, phosphorus acid. Then again remove an oxygen from us acid. I get what? Hypo acid. What is ic acid? We know very well for phosphorus. H3PO4, ortho phosphoric acid. Remove an oxygen. What will happen? H3PO3. And remove an oxygen. I get what? H3 and PO2. This is what? Hypophosphorus acid. This is called hypophosphorus acid. Understand? Now, what is the general formula for oxide acid of phosphorus? The P double bond O OH. This is what? The common unit for what? All the oxide acid of phosphorus. Now, therefore, what is the formula? H3PO2. Therefore, only one H, the 3H. Therefore, I put one H here and one H here. Now, the formula can be satisfied, right? Therefore, how many number of pH bond? The number of the pH bond equal to what? The 1, 2. The answer is 2. This is NAT question. Okay, this is what? The NAT numerical answering type JAM 2016 question. Please understand. Very simple, right? It's a trick. It's a trick to find out what? The type of oxy acid of phosphorus. First, ic acid, remove oxygen, you get us acid. Remove oxygen, you get what? Hypo acid. Very simple. Okay. I go for seventh question. This also very simple. Okay. Similar to what? That polysulfur SS linkage. That type of question. Okay. They ask what? The number of the SS bond in tetrathionate ion. What is tetrathionate? Please note. This is a formula. S double bond O and double bond O, here SCN and S double bond O and double bond O, here OHH. This is okay, thionous acid. Now I remove what? This thionic acid. Remove what? This is thionic acid. This is thionic acid. I remove H plus here and S double bond O and S double bond O and SN and S double bond O and double bond O, here O minus and here O minus. This is called what? That thionate. This is thionate. They are asking tetra, right? Therefore, 4 sulfur. So 1, 2, 3 only. Therefore, what is N value? I put N value is equal to 2. What is the formula is convert to? Yes. Okay, I write here. Okay. Yes. Double bond O and double bond O, here O minus, here S and S and S double bond O and S double bond O minus. They are asking what? The number of SS linkage. Therefore, there are 1 SS and 2 SS and 3 SS. What is answer? Answer, the 3 SS bond present what? The tetrahydrogenate ion. Very simple. This is a formula, right? S double bond O, here double bond O, here sulfur, here sulfur, here sulfur, and double bond O, here O minus, here O minus. This is what? Tetrahydrogenate. How many SS bond? 1 SS1 and 2 and 3 SS1 option. Answer is 3. It's a NAT question. JAM 2017 question. Okay. I go for question number 8. Now they're asking what? The number of in the structure, the P4O10, the number of POP bond. I discussed this is what? Oxide of phosphorus. What is the concept? This oxide of phosphorus. We discussing already, right? Oxide of phosphorus. Now what is the trick for the always which structure they form? Adamantine structure, right? Adamantine. What is adamantine structure? This adamantine structure. This adamantine structure. Okay, always what? The oxide of phosphorus can exist this form. Now this is P4O10, right? What is the general unit for oxide of phosphorus? That is P4O6, right? First draw P4O6, the phosphorus, here oxygen, here phosphorus, here oxygen, here phosphorus, here oxygen. Okay, now this adamantine phosphorus, here oxygen, then here oxygen. Okay, this is what? The 1, 2, 3, 4. This is P4O6. How to convert to P4O6 to P4O10? Make what? P double bond O bond. How many remaining? 4, right? Therefore, 1 P double bond O and other P double bond O and next P double bond O and P double. This is what? This is P4O10. Okay. Simple way to draw the structure. Okay. I discussed the previous, I think lecture 11, I discussed this concept, right? Now count how many POP bond? 1 POP and 2, right? 3. How many? You count. Answer is 6. Okay. We get the 6 POP bond. Count the bond. Very simple. Okay. This is 1. Okay. Now this is 2. This is 3. This is 4. This is 5. This is 6. Total how many POP bond? The 6 POP bond. Okay. Let's go for next question. Next question same. Okay. Simple question. Choose the correct statement for expert to what? Hypophosphorus. Just now see the structure of hypophosphorus acid, right? What is hypophosphorus acid? That is H2PO2. This is hypophosphorus acid. What is structure? Common structure? The P double bond O and OH. This is common one. Now I put only what? S3. Okay, S3PO. Therefore I put HH. Now read the option. Number is a number of OH. Number of OH that is equal to basicity. Okay, basicity. Now, how many OH? Only one OH. Number of OH equal to 1. Therefore, this is monobasic acid. This is monobasic. Very simple. This is monobasic. Now, how many pH bond? The number of the pH bonds equal to what? The 1, 2. Now read the option. It is dibasic. No, it's a monobasic, right? It's a monobasic. It is 1 pH. No, it's a 2 pH bond. It is dibasic and 1 pH bond. It's wrong. It is monobasic and 2 pH bond. Answer D is correct. Simple question, right? If you know the structure of oxyacid of phosphorus, we can find out what this type of the dibasic, a number of pH bond, a number of POP bond, a number of P double bond O bond. We can find out using what? The trick. I discussed a trick in previous class, right? Now go for next question. Simple, same question. Okay. Hyderabad 2016 question. They're asking what? The number of type of bond. 2 center 3 electron bond and 2 center 2 electron bond. We already discussed the diborane and boron. Here hydrogen. Here boron. Here what? Hydrogen. Here hydrogen and hydrogen and hydrogen and hydrogen. Now you know very well this bond. Okay, this one nothing but what? The 3 center 2 electron. This nothing but what? The 3 center 2 electron. Other 4 bonds what? The 2 center 2 electron. Therefore, the 3 center 2 electron bond equal to 2 and the 2 center and 2 electron bond are equal to 4. Therefore, here 6 wrong. The 4 2 center 2 electron and the 2 3 center is correct, right? Therefore, not only 2 the only what? Only the 4, right? What is answer? Answer is 4, the 2 center 2 electron bond and the 2, the 3 center, the 2 electron bond, BHP bond is present. Very important. Okay. Go for next question. They are asking what? The structure of BCl3 and ALS3 in liquid state respectively. Listen. In very important, please note this concept. In BCl3, okay. Now, due to the bigger size of chlorine atom. At the same time, at the smaller size of boron atom always exists as monomer, not dimer. Monomer. Okay. Now first point. But in case of AlCl3, okay, this always make what? Dimer from Al2Cl6. Okay, we discussed this structure in what? The multi-center compound. This is a multi-center compound. Therefore, due to what? Due to the bigger size of aluminium, they make always form the dimeric form. The dimeric form is the more stable compared to monomeric form. Therefore, and AlCl3 always make what? Dimer, right? Have a monomer cut, and BCl3 always make monomer. Therefore, option D is correct. The monomer and the dimeric form. Okay. I go for next question. The formula for the basic structure of unit one-dimensional silicate. Very important. What is one-dimensional? Please note. What is mean one-dimensional silicate? One-dimensional silicate. That means what? The one oxygen chair. Only the one oxygen chair. Now what is the answer? This is SiO3 2 minus. This unit. Now see, this is one silicon. This is what? This one unit, SiO3. You combine this pyrosilicate. Okay, pyrosilicate. Okay, pyrosilicate only what? The one-dimensional silicate. This one-dimensional silicate, which is pyrosilicate. SiO3 2 minus the pyrosilicate. Others are what? The two-dimensional, three-dimensional silicates. This is orthosilicate. Okay, this is what? The two-dimensional silicates. Let's go for next question. The first noble gas compound reported in. Okay, I discussed the Xenon compound. What is the first noble gas report, sir? This is what you have to learn it. What is learn it? We have to read. There is no other way. What is the answer? Answer is the xenon, the platinum complex, the Pt and F and 6 here plus here minus. Okay, this compound what? The first reported the xenon compound. Okay, very important. Please note it. Now 14, very simple question. The Mg2SiO4 belong to the class of which silicate? Now see, very simple. I take magnesium Mg2SiO4. Now separate the silicate to Mg2 plus SiO4 4 minus. This is what? The basic unit of silicate. What type of silicate? This is orthosilicate, right? Orthosilicate. Therefore, answer is the orthosilicate. Very simple question. Now, last question today's section. Which of the following fluorides is not formed by the xenon? Now see, XCF2 is formed, right? And XCF4 is formed, and XCF6 formed, but which is not formed? The XCF3 is not formed. Please note. Okay, the XCF3 is not formed. Not formed. Why? Because okay, the structure is unstable. If we try to write the structure, for example, xenon, the 8 electron, right? 1, 2, 3, 4, 5, 6, 7, 8. 3 fluorine, 1 fluorine, and 2 fluorine, and 3 fluorine. I make 3 fluorine. Now make a lone pair, 1 pair, and 2 pair. Only single electron, right? This never, okay, single electron species always more reactive, right? It never exists like what? Monomer, always convert dimeric form. Okay, this not exist as monomer. Is always convert to what? They convert to the dimeric form. Therefore, the XCF3 molecule does not exist in the xenon fluoride molecule. Okay, I hope understand all the 15 questions. Okay, thank you so much for watching, and see you next video and as soon as possible, and tata, bye bye.